So in this video, we're going to look at the Java memory model, and more specifically, the use case that I'm going to play with here is the singleton design pattern, where I have my two classes, the file system class, which is over here. The first one is a file system class, and I've got my finder window class here. And one small slight change to my code here. I've just made the F in the file system an uppercase F there, and I've made the F in my Finder window an uppercase F there, just to be consistent with our coding style that we have been following in this semester. Okay, so first thing, we need to draw a stack and a heap here. So let's use orange to draw the stack region of our memory. And let's draw a vertical line here, and let's use maybe yellow to draw the static heap space of the memory. So the static heap space of the memory, and maybe let's just use blue. Let's just use blue to draw, I don't know, this looks like an aqua, so maybe it's aqua. So let's just use aqua to draw the object space of the heap. Okay, so this is an object space of the heap here. All right, and so just to tie up things from what we've been doing so far is all the instances that we create will reside and live on the object heap space, which is this region over here, and all the static entities of the class will reside on the static heap space of the memory, and all the local variables and all the function invocations that happen as the code executes will reside on the stack space of the memory. And again, you create these stack frames when function gets called, and you will remove these stack frames as the function gets returned and terminated. Okay, so first thing, let's look at the main function here. The main function happens to be inside the Finder window class, which is right here. This is going to be the starting place of the execution of my code here. Okay, so first thing, as this code starts executing, the class that gets loaded is the Finder window class as the first class that gets loaded in memory. So I'm just going to draw a box here. I'm just going to draw a box on my static heap space, and this box over here is, we're going to give it a name, and the name is going to be, in this case, a Finder window. So this is going to be, let's use FW for short. Okay, so I'm using the acronym FW short for Finder window, and this is going to contain the definition of the static members that happen to be inside the Finder window class, which currently this class Finder window apparently only has one static member, which is the static main function right here. Okay, so let's go on and let's get this static main function present. So this is my main function, okay, which happens to be the static member inside the Finder window class. And the very first line, as the main function executes, is we're going to create a stack frame. We're going to create a stack frame which indicates that the function that is currently executing, is the main function. So again, just to be consistent with some terminologies and to be consistent with some way I'm going to put this figure together, let's just use this upper box over here to indicate the name of the class. The name of the class here is Finder window, and the function that is currently executing inside the Finder window class is the main function. Okay, so I have my first stack frame on my stack, and the very first line on my stack frame over here initializes what I have here is a Finder window, fw1 equals to new Finder window. So what I have here is my local variable, the first local reference fw1 created on the stack frame, and what I have now is a call to a constructor. So I'm saying new Finder window. This will go ahead and create a new stack frame for me. This creates a new stack frame for me because it's a new new function call, a new constructor invocation here, and this constructor invocation is going to create a new stack frame. And again, this stack frame, the new stack frame happens to have a name, is a constructor. So let's just call fw, that's the name of the function, the name of the method that is currently executing, which happens to be the name of the constructor, and this constructor belongs to the class fw. Okay, all right, so what's happening on the constructor of public of finder window? So the constructor of the finder window over here, so let's just go ahead and create a instance, because the moment I have new finder window, this piece of the code is going to instantiate, is going to create an instance of the finder window on the object heap space. So let's go on to the object heap space, let's create our instance, and this instance happens to be a finder window instance. So let's just give it a name here, finder window instance. And what are the instance members inside this finder window instance? So if I look at my finder window class here, I can see one of the instances that this class happens to have is a reference to file system of type file system. This is an instance member. This code over here is an instance member. So let's just use short for RTFS. So I'm going to use RTFS for short. Okay, that's an instance member, and it's an instance member and it resides on the instance, inside the instance here. Okay, so what let's go back to a stack frame, and from the stack frame I have a local reference, which is basically this. So you can think of this as actually pointing at this instance. So first thing what I have here is I have my reference this. Okay, and this is basically the reference that points at this instance. And am I instantiating any local variables as my constructor of the finder window gets called? So if I look at my constructor of my finder window here, there's no initialization or declaration of any local variables. So the only thing that this method does here is says reference to file system equals to file system dot create file system instance. So I have a new method call. A new method call is create file system instance, which happens to be inside the constructor. The constructor hasn't returned yet, and because the constructor hasn't returned yet, I'm going to have a new stack frame getting created here. And this new stack frame that gets created happens to be referring to create file system instance, which happens to be a static member inside the class file system. So again, on the static heap space, what I need over here is a new class that gets loaded, which happens to be the file system class, and let's just use FS for short, which happens to contain two static members. The first static member that this class contains is this piece over here, which is a reference called single reference, and single reference happens to be of type file system. So I'm going to have inside my class here, let's use SR for short, that refers to single reference. Okay, that currently is pointing at null. Okay, and it also has a method create file system instance. So let's use CFSI short. That basically refers to the method definition, which is a static member inside the class file system. Okay, so as I call my method create file system instance, which happens to be part of the class file system. So let's use FS for short, and the method is CFSI, which is create file system instance. And this method, as it executes, it checks for single reference is equal to null. If I look at my single reference, which happens to be a static member inside the class file system, it is actually null at this time. Because it is null, I'm going to say single reference equals to new file system, because this piece of the code has been set to true. This Boolean expression is true, and because it is true, this line will execute, and that line over there says single reference equals to new file system. So what I have now is I'm going to instantiate something on the heap, because I have my new keyword there. I have my new keyword here, which is right here. That's my new keyword, followed by the constructor that is going to instantiate a file system instance on the object heap space. So my picture, SR at this point is now going to point somewhere on the heap, that happens to be the object of the file system. Okay, so this is now a file system instance, and this instance is going to contain all the instance specific members of the file system instance. And if I look at my class here, the file system, this is just a boilerplate code here, but the only instance specific happens to be, in this case, just the constructor there. It's just a constructor here, which is a private constructor. So let's just create FS for short. Okay, that's the constructor, and of course this class could be expanded to contain other instances that may be specific to a file system. So what I'm going to do right now is I'm going to pause my video here, and we're going to continue looking at this Java memory model in the second part of the video.